Good morning, everybody. As Richard said, my name is Dirk Slama. I work for Bosch. We are not the smallest manufacturer on this planet, I would say. We have about 250 factories worldwide and produce a number of very different things in these manufacturing. So, for example, we're the world's largest manufacturer of MEMS sensors. I would say 50% chance that you have a sensor from Bosch in your smartphone in your pocket. A good chance that some of you will have a Bosch refrigerator in your kitchen. A very good chance that the car that brought you from the airport to this place had many Bosch components in it. So we've been doing this for 130 years, and naturally for us this is hugely important because we see that all of this has not only the potential, all of this is actually transforming what we're doing and how we're doing this. So what I would like to do is to use the next 30 minutes to share from a Bosch perspective where we see A, this whole journey going, and B, the value add of IIC in this for the community and for us as a specific example. So everybody is talking about this. Not everybody at Bosch would be able to read this. This is using syntax that's only accessible to computer science guys, simple BNF that explains the world. One challenge for us is that we need to bring these worlds together to make this work. Why? Because this is changing everything for us. We've seen some examples where this already happened. I mean, everybody wants to be an Apple, not only because they are the coolest company in the world, and you know, I live in Berlin, so in the cool parts of Berlin where you have the people still driving a Saab car, they have the Apple on the bumper sticker. So not only because they're a cool company or because they're massively profitable, generating huge revenues, but because they have really mastered this. They have gone from, you know, a company in the league of, you know, selling Walkman or iPods to a company that actually has built an ecosystem that locks people in, because today this is not about making a decision, I need a new telephone, and I spend hours looking at what type of telephone do I want. This is a question of, well, now I had my accounts with them for 5 years and they know everything about me and they make my life comfortable and they make sure that my kids are not doing stupid things on the internet, and yeah, of course I upgrade on a regular basis, these kind of things. As a car manufacturer, that is a dream, because when you buy a car and you use it for, I don't know, whatever number of years, and you decide you need a new car, it's open, right? This kind of lock-in you don't see in other industries where people basically are hooked to your platform and then upgrading the hardware becomes a regular thing, right? So this is about basically the next generation of products and how we are actually manufacturing these products. Okay, so from a car manufacturer's perspective, in the past, you know, once the car left the factory, it was gone. And if you were lucky, maybe a year later, the guy would come back into one of your garages. If we were lucky, he would come into one of our garages, or he might have gone to a completely different garage. But you were out of control what happened with your product. In a world of connected products, obviously, the moment your product leaves the factory, this is where the fun starts, because that means you can be in constant contact with your customer. You learn how the customer is using the product. Okay. A lot of the people who are looking at this actually from a manufacturing point of view, their immediate reaction is to go and say like, oh yeah, great, we can deploy remote condition monitoring, or if we're really good, predictive, preventive, prescriptive maintenance, but it's all about maintenance. This is one part of the equation. Okay, but a lot of people are also looking at this naturally from what is the customer experience? How can we improve the customer experience? How can we use this to deliver digital services, right? So somebody buys a car, and I don't know about your company, but when I get a company car, they're a bit stingy. So they say, well, you don't need a Porsche to do your work. But what if they give me the car, and the next time somebody figures that I want to spend the weekend driving in the mountains of Switzerland, I get an email saying like, Dirk, how about we give you an extra 20 horsepowers for your car for the next 48 hours for 25 euro cents. Okay? So this is where the fun starts. And that basically means, yes, there's a lot of opportunity, but also there are a lot of challenges. So I was making this joke early on about the different languages. I came to Bosch from a startup company. The company I was working for was acquired 6 years ago, and I knew nothing about manufacturing. I was one of these dudes that was sitting in these fancy Berlin coffee places where everybody sits with this Apple laptop, and you actually don't work anymore. You do projects, and you do them in coffee bars, right? The Bosch people, they have this thing, it's this big red button, right? And they spend years preparing, and then once they're ready with the product, they press this start of production, SOP button. And they know after they have pressed this button, they cannot change things anymore, right? Us internet people, we're used to, do our projects in a coffee bar and then deploy it, try it out. If it works, great. If it doesn't work out, I change it. Everybody here is using, I don't know, Facebook, Amazon, whatever. These guys are using you as guinea pigs. They are rolling out small, minor patches nearly on an hourly basis, and they try them out with 100 people. If that works out, they try them out with 1,000 people. If that works out, they try them out with 10,000 people. If that works out, they make this new feature available to billions of people, and all of that in a matter of 24 hours. If you're a manufacturer, after you press this start of production button and your physical asset is leaving the factory and is deployed in the field, there is no way back. You cannot simply go out and fix 1 million products, or if you have to do, it's really bad news in the press. Yeah. So there's a lot that needs to be done in terms of bringing the thinking of these two different worlds, the cultures of these two different worlds, the way how they work together, right? Bringing the agile and the more traditional, very long-term planning-oriented manufacturing way of working together, and also to design products that live this. I mean, if I look, for example, at a Tesla car, Tesla sometimes is building physical features into a car, like certain sensors, because they have a hunch that a year from now, the next software release can make good use of this sensor. But they don't yet have the software. Okay? And they need to somehow manage the physical design of the car and the current and future design of the software on the car, in the cloud, and so on, and get all of this working. Okay? So this is the challenge. And from our point of view, we've been working very closely now for the better part of 2 years with the ISC, and I wanted to share a little bit what we've learned, how the ISC helps us with addressing these challenges. Okay, so there's a number of different things. Richard touched on all of them. There's testbeds, there's reference architectures, there's best practices, there's interoperability, and at the end of the day, there's putting this out in the field and making this work. Right. So let me start with testbeds. What is a testbed? And actually, I do believe if you go to the ISC website, there is now a formal definition of what is a testbed. But let's put this aside and let me explain what I think a testbed is, at least how we have experienced this. A testbed is a micro consortium of people who actually want to work together. Who want to work together. That is super important, because if you look at larger consortia, if you look at ISC or other consortia. You have many companies. Richard mentioned 270 companies now at ISC. I mean, it's 3 weeks until Christmas, but if you tell me that all of these 270 companies really want to work together all the time, then good luck with unpacking your Christmas presents. A testbed typically is a handful of companies, 2, 3, 4, 5 companies that see, okay, we all live in a cooperative environment, but for this particular testbed, it makes total sense for us to work together and to move this particular challenge forward and find a solution for it. And that's what we love about testbeds. So this testbed that Richard mentioned early on, the track and trace testbed, I think from the perspective of this company that I mentioned earlier on that has potentially thousands of people working years until they press this button, it was a revelation for us to see that we can actually come up with an idea, implement it, and take it to market and have a first commercial deployment in less than a year. That was unheard of. Okay, so this speed that we are getting into innovation through this mechanism of testbeds, I think is extremely important. So to just give you one example, so this track and trace testbed that Richard mentioned, this was initiated by one of our divisions that's specializing in process tools for manufacturing. So we're talking about highly advanced tools for tightening, drilling, welding, measurement, and so on. And these type of tools actually have become smart, intelligent IoT solutions these days. So what used to be a tightening system, where I have an industrial PC and a hose and then the tightening tool, has actually become something that now looks like, you know, a tightening tool that you can buy at Walmart, except that it's a high-end tool that has onboard logic that controls your tightening process and so on. And the huge challenge that we faced is, how do I actually embed these kind of solutions in a manufacturing environment, right? So how can I make sure that the tools with the right calibration, the right configuration are made available to the people when they need them, that they're recharged, that they're configured with the right program for the particular task at hand? How can we make sure, for example, that we're getting data from these tools for each process step? We have customers who perform in a single factory more than 100 million tightening processes per year. Okay? And we want to be able to create a record of each of these tightening processes so that we can create basically a quality lot for every step in the process that has the complete curve, torque and angle for each process step. Okay, and this is basically where we started off with track and trace. With these kind of use cases, most recently we have extended this use case to also go in the area more of factory logistics, intralogistics. So we have extended the testbed to also focus on the use on tracking and tracing of forklifts. Many different stakeholders for this type of solution. So plant logistics people have huge demands. The fleet managers, for example, I'm just looking at our Traunreuth warehouse that's managing the output of BSH, so refrigerators, ovens, and so on. Millions per year. They have a fleet of 35 forklifts, okay, and they can use this solution to optimize the way how they handle their internal logistics and make sure that our products reach the customer on time. So huge benefit. As I said, for us, this testbed was an opportunity to develop this partner ecosystem. So for this extension of the track and trace testbed with a focus on forklifts, we worked together with SAP, who now became a partner in this testbed, and was a great opportunity for us to try out this new solution from a technology point of view, but also from a joint go-to-market point of view, because that's also not trivial, right? So how do you design a new solution, and how do you get your sales forces, your marketing organizations aligned on taking this solution to market, okay? So I think this clear market focus also is a great benefit that we're getting out of this testbed approach. The next thing, reference architectures. I was talking earlier on about these different perspectives, viewpoints, if you like, that you have in an IoT project, and this is exactly what the IC reference architecture is addressing. In fact, it has these different viewpoints built in. So it is actually based on the concept of multiple viewpoints that capture specific perspectives on an IoT solution, okay, help you drill in. So for example, here we see the breakout for the functional perspective of a reference architecture, but also to make sure that we can align these different perspectives from the business perspective down to the technical implementation perspective. So in a sense, that really helps us to build bridges between these different stakeholders in such a project. And Richard mentioned earlier on, IC is not the only consortium alone in this space. There's, for example, Industry 4.0, which started with a very strong focus on manufacturing, so on the manufacturing perspective. And what we did is we spent the last 12 months on aligning these two organizations and what we're doing, and in particular aligning the perspective on reference architectures. So what we've learned is that if we can actually combine the IC reference architecture and the Industry 4.0 reference architecture, it really helps us addressing this entire value chain that I was talking about earlier on, from the how do we manufacture our products, but also how can we make sure that the design of these products fits into the world of connected, intelligent solutions. Now, obviously, a reference architecture is something that's, how can I say this politely, not easily digestible for non-experts. Okay, so I mean, one great benefit of the IC is that it's actually bringing together these experts. But when you're a project manager and your challenge is to actually go out there and build a track and trace solution for forklifts, okay, then maybe reading a 200-page document on reference architectures is not your first concern. Your first concerns are getting money, getting the people work together, sometimes resetting and getting them to work together again. So these are the kinds of things that keep you busy. So good thing is that what we're currently enabling at the IC is that we're taking what we're learning from testbeds and what we have in our reference architectures, and we're bringing this into best practices, and these best practices actually are leveraging a concept that's called gamification, because sometimes it's just a good idea to make it fun to do these things. Okay, so what we developed is a kit for a consultant that works in this type of environment, who wants to bring in the benefits, for example, of using reference architectures into a situation where he has, for example, the solution architect, the business stakeholder, etc., sitting together and wanting to come up with a solution design and an implementation plan. And he can use this toolkit to structure the workshops which are typically required to do all of that, okay, to make sure that we get a very solid specification for our project, and that we're not forgetting any of the complex dependencies which are typically built into this. And this toolkit is basically looking at two perspectives. One perspective is the plan, build, run perspective, which is more concerned with the end product. Okay, so I mentioned this forklift test beds earlier on, where we need to deploy sensors on the forklift, we need connectivity to the cloud, and then we have the track and trace solution running in the cloud. Okay, so this is done by people who, well, naturally understand cloud, telecommunication, sensors, and so on, right? And also by people who actually understand forklifts and warehouses and tell them, you know, what kind of data do I need to support my use cases and what kind of processes do I need to implement in the cloud in the backend. Okay, so this is what the best practices framework from IIC is addressing. It's actually quite neat. It's a box about yay big, and it contains pretty much everything you need to run a successful 2-day workshop to come up with a very solid and reliable specification that helps you minimizing your project risks and speeding up time to market. Now, that's one half of the equation. The other half of the equation is we obviously don't want to do this all as a retrofit all the time in the future. So we want to be able to work with forklift manufacturers who build this solution into their forklifts as they leave the factory. So that means that we also need to address the way how the forklift product is designed. Okay, so what additional joints do I need to add to my PLM model to fit in the sensors? Do I need to add a new powertrain link to link in these sensors? Where do I actually put in my telematics unit? How can I test this both in the country where I'm manufacturing these things and as well in the country where I'm rolling these out? Okay, so these are a lot of very manufacturing process specific questions, and this is basically where I think also this liaison between IIC and I4O really comes to fruition, because we have extended this framework to also address this, what we've called asset preparation, which basically means changing your product design, changing your production line design to produce forklifts, for example, that fit the needs of the track and trace solution. Okay, and last thing, then obviously, in order for all of this to work, in a way where all of these different components are playing seamlessly together, obviously interoperability is super important. So for us, a key thing is to make sure that out of these test beds that IIC is implementing, we can also generate proposals for new standards. So here's just one example that came out of a testbed that we have been driving, that is starting with the open source approach to standardization, and now in the next phase basically is taken back to IC to help us making sure that these things that are coming out of the testbeds are properly fit into the overall landscape. Okay, and this is where the IC's Industrial Internet Interoperability Coalition approach comes from. So I3C is basically the idea that IC is coordinating and liaising with all of the different standards, organizations and bodies. Richard had a couple of them on his list earlier on, to make sure that we understand how all of these different standards are fitting together and can be leveraged in this IC framework's perspective. So for track and trace, for example, we need standards that address the cloud side of things, that address the telecommunications and the semantics of the data that we pass back and forth from the forklifts to the cloud, and for example, basic things that allow us, and I think that's super important, to have a standardized hardware and software API that allows us to deal with the battery. Right, so why do I have to reinvent this every time I'm doing track and trace for a new device, for forklifts, for power tools, and next year for what have you. Okay, so we want a standard that allows us to plug into batteries and manage them and get the battery load on a standardized level without reinventing the wheel. So I3C is basically helping us to make sure that all of this is working together, and IC is the facilitator that brings all of this to work. So with that, I hope I managed to bring across in this half an hour where we think IC is really helping making this beautiful new world of intelligent connected products come to fruition, from testbeds to reference architectures, best practices, and interoperability. With that, I'd like to thank you, and up to the next speaker. Thank you.